then from year to year you can repeat what you have been doing. Unfortunately, scientists are too clever, so they complicate it from the very beginning, and on the next year they see they're doing something wrong, and on the third year they change something, so the monitoring itself never works properly. So the International Snow Leopard Trust has been very fortunate to provide a handbook where it makes a standard of procedures for conducting snow leopard status and distribution and habitat surveys. So, following this survey routine method, we are doing the same what researchers are doing somewhere in Nepal, Pakistan, India, China, so we can then compare our results. So, what is left behind by the team members? These are data sheets. So this is the most important product which is produced by the team members for the 2 weeks while they are doing the research. So usually I choose some kind of route, transect, which will be, say, 10 or 12 kilometers long. And then we write down, so this has been the whole team, we have the date. Then we've come across, then you have snow leopard sign. So par marks, that's a track. Then you have scrapes. Scrapes, that's when the animal urinates and makes like a cat makes a scrape. Then you have feces, that's the dropping, the shit. And urination, so that will be a spot. And rock scents, that's when the animal makes a scent mark on a rock which is used for territorial marking. So here we've come across other marks. So we write down the coordinates, we write down the measurements of the paw. Here we have this research effort, the search effort. So usually that's done in kilometers, but because this is mountain, so you go up and down, it can be 1 kilometer, but the whole day. So the research effort is usually in time. So say this was started at 10 and ended at 4 o'clock. Then there's a unified methodology for giving the features of the terrain, of the physical environment. So that can be gently rolling hills, then steeply rolling, broken terrain, that's a lot of log rocks and cliff, and so on. So you write down the kind of terrain, threats to snow leopard. So here everybody makes notes during their survey. Have they come across vehicle tracks, sign of grazing? Have they seen those domestic animals? Are they tourists? Is it trash, campfires, everything which gives you a sign that the animal can be at that place disturbed. On the other side, we write down all the sign of the prey species which has been met. So this has ibex. We have the coordinates. We write down what kind of sign it was, species, or observations, how many animals there were. For instance, 2 adults here. Then we have hare, mountain hare, musk deer, wild boar. We didn't see the wild boar, but we saw diggings. Pika, there's a pika table. Can't see it here. Something else. Then Altai snowcock, that's a big game bird, which also can be a secondary prey species for the snow leopard. The same is done for birds. So there's a tick list which we fill in after the survey in the evening time. So what we do here is just also we can, for instance, Altai snowcock. We didn't see the snowcock, but we saw feces, droppings. Here are the droppings, you see, and that's the feather. So we make a record that we saw that the Altai snowcock is in place. And all these birds, that's all the birds which we had seen during that day. So the Altai snowcock, rock ptarmigan, cuckoo, we didn't see the cuckoo but we heard it, black-eared kite, a kestrel here, then the two highland birds, the chubs, yellow-billed chub, red-billed chub, northern wheatears, Himalayan griffon, rufous-backed red-star. So, Altai accent is quite a rare bird. So, that's a record for one day. But every day we make the same kind of record. If the team splits into two, they will make their own records. And later on, this can be summarized. You can have a series of observations which can be common, can be rare. You can apply, say, the Shannon index to measure the diversity. You can compare habitats. You can see how many raptors and non-raptors are living in the place, which is actually a good indication of the habitat quality. So the same is done for mammals. So most of these mammals, we didn't see them, but we saw the sign and tracks which they leave behind. For instance, we didn't see the wolverine on that day, but we found tracks in the snow which were fresh and a clear indication that the animal is there. So from those data sheets, the data is collated and produced in a report where, say, for instance, this study area, which covers around 200 square kilometers, shows where plug marks have been found, scrapes. This is the base camp here. It's quite close to the base camp where the snow is, but it was roaming. Yes. Here over there you have this is overnight camp. So from this point we would be studying these ridges over here, and for each year the same kind of map is being produced, and it also has been used for compiling a digital model of the distribution of snow leopard in the Altai, but I won't be saying nothing about that today. So also you can extract from those data sheets the kind of habitat, so which is connected with those findings. So here you have narrow valley, so these are narrow valleys, broken terrain, you see rocks, quite bare here, steeply rolling hills, and other landforms. So it can be in stream beds, glacial lakes, gently rolling hills, forests, other stream beds, things like that. Also, you can extract from those data, from the data sheets, a summary of prey species. So, how often you have come across a sign of this or another species. So, here we take into account Altai around 28%, ibex, game bird, peacock, hare, marmot, and other animals which can be red deer, can be roe deer, other animals such as wild boar and so on, which compile together 6%. So all this gives you an indication of what kind of habitat it is. Is it suitable or not suitable for the animal itself? Well, here we'll reach only in this report one complication, and this is connected with the problem that total count methods are difficult to apply in the area, and an option is to focus on relative abundance methods which may produce an index, so the word is here, reflecting the density of the prey species population. And one such approach is to analyze how fast we are collecting our data, assuming that the more animals are in the area, the more sign they will be producing. We'll say if you visit a beach and there are only few people there, so you will get only a few footprints around. But if there are a crowd of people on the beach, of course there will be more footprints there. So that's the simple idea behind assuming that if we can accomplish this by plotting cumulated numbers of sign against the dates from the beginning of the survey up to its end, and estimating the corresponding regression values, we can get regression coefficients which directly or indirectly will be reflecting the numbers of species. Because if there are only a few species, numbers around, so you see one animal today, maybe tomorrow you'll see another animal. 1 plus 1 will be 2. On the day after you'll see 2 animals. That will be already 4. So this piles up rather slowly or at a faster rate. And this is reflected by regression coefficients. So if you say compare 2006 and 2005, the regression coefficient is around 3 times larger. So we can suppose, perhaps, that the numbers have risen 3 times. So if we do this from year to year, we get a vision of how the numbers change throughout the whole survey, years of survey. So here you have the consecutive years, and you see for Agami, which are the red colors, it's a steady decline, and when you visit the area for many times, you have the feeling that there's less and less mountain sheep occurring. Whereas ibex, the yellow color, is going up and down, so it's just fluctuating. But unfortunately, the snow leopard numbers are in a steady decline. So perhaps one conclusion may be that numbers of Siberian ibex, recognized as the most important prey species for the snow leopard in the area, have seen both ups and downs. So it's going like that. However, records of snow leopard are becoming increasingly scarce, so it's going down. And the apparent disconnection between numbers of the primary prey species and numbers of the predator, which are going down, are disconnected, so there perhaps are other factors which are driving down the numbers of snow leopard. And we conclude that perhaps this is an increasing disturbance and perhaps poaching, which is suppressing numbers of snow leopard. But one of the conclusions of the expedition is that the physical habitat is suitable for the animal, and there's also a healthy prey base, particularly ibex. So all that would be needed to support the numbers of snow leopard would be to declare the area as protected. And in that way, it would be favorable for the snow leopard. Well, each year reports are produced, so you can reach them through the website, and some publications have been done